The number one question is, what is a set? A set is a collection of objects called elements or members of that set. There are three ways to describe a set: with a description, in roster form, or in set builder notation. A description is simply a written description of the set's contents. In roster form, the elements are listed inside of a set of braces and separated with commas. The example for set builder notation is read as set E is the set of all elements X such that X is a natural number greater than 10. Two types of sets are finite and infinite. In a finite set, there is a set of natural numbers with a beginning and an end. In infinite sets, they seem to go on forever. There is no set endpoint. The universal set is symbolized by U. It contains all of the elements for a specific set. An empty set, also known as a null set, contains no elements and is within empty brackets. Equal sets occur when two or more sets contain the exact same elements. Equivalent sets occur when there are the same number of elements in two or more sets. Something important to keep in mind is subsets. A subset is, all of the elements of set A are also elements of set B. It is not a subset when at least one element of set A is not in set B. Here are some examples of how to write out subsets. The first one shows that A is a subset of B. The second shows that A is not a subset of B. And the third, A is a proper subset of B. Here is an example that has to do with subsets. Set A contains marigold, pansy, and geranium. Set B contains marigold, pansy, geranium, and magnolia. Set A is a subset of set B because everything in set A is contained inside of set B. Another example of subsets is set A is 2, 3, 4, and 5, and set B is 2 and 3. Set A is not a subset of set B because not all of the elements in set A are in set B. There are 4 different ways that two sets may be represented in a Venn diagram. One way to represent A and B in Venn diagrams are when A and B are disjoint. This means that no elements in set A and B are the same. When A is a proper subset of B, everything in A is contained in set B. When set A and set B are equal, they are represented by the same circle in a Venn diagram. The intersection of set A and set B is the area that is contained in both set A and set B. This is what set A and B have in common. There are several important vocabulary terms to know. Intersection, where all elements that are common to both A and B. Union, elements that are members of A, B, and their intersection. Complement, set of elements in the universal set that is not in the given set. Here is the way intersection, union, and complement are written. Keep in mind that and will always mean intersection and or will always be union. This is a basic Venn diagram that shows the 8 different regions. Region 1 contains elements that are in set A that are not in set B or set C. Region 2 contains elements that are in set A and set C but not in set B. Region 3 contains the elements that are in set B but not in set A or set C. Region 4 contains the elements that are in set A and set C but are not in set B. Region 5 contains elements that are in sets A, B, and C. Region 6 contains elements that are in set B and set C but are not in set A. Region 7 contains elements that are in set C but are not in set A or set B. Region 8 contains all the elements in the universal set that do not fall into regions 1 through 7. These are two of De Morgan's laws. The first reads, the complement of A union B is the same as the intersection between the complement of A and the complement of B. The second law states that the intersection of A and B is the same as the union between the complement of A and the complement of B. For the example with these 4 sets, we will be breaking it into 8 separate regions. Each of the 8 regions is broken down on the left, where in the top of your screen you can see the Venn diagram holding each of the numbers. And that wraps up our lesson on sets. Thank you so much for your time.